Hello students, we have done different separation methods for different mixtures, like ink is a mixture, water can be separated from the pigment of ink, cream from milk we did, immiscible liquids which are not soluble into each other, and the mixture of ink. Suppose we are mixing different colored inks together, then they can also be separated. Okay students, now today I am taking how to separate a mixture of two miscible liquids. This time miscible liquids, I am giving emphasis on miscible liquids. Miscible meaning students soluble. So here I am taking, suppose, acetone and water. एसीटोन, इफ़ यू आर नॉट नोइंग, आई एम टेलिंग यू, नेल पॉलिश रिमूवर, जिससे हम नेल पॉलिश हटाते हैं, दैट केमिकल इज एक्चुअली एसीटोन. इट इज completely soluble in water. After mixing these two together, how can we separate this mixture? These two liquids are soluble into each other, miscible into each other. Then how to separate these two components? So here I am telling you students that if the boiling point you know now students, the temperature at which liquids start boiling, if the boiling point difference of the two component is more than 25 degrees, I am not writing here Celsius or Kelvin, 25 डिग्री का डिफरेंस है बॉइलिंग पॉइंट में दो कंपोनेंट्स का, 25 से ज़्यादा, मोर देन 25, then that two components can be separated by simple distillation. This name is not new for you students. Simple distillation. What is that? I will tell you in detail. Firstly, I am taking some example. Like in a mixture, A and B components are there. I am just supposing that A component and B component is there. A is having boiling point 35 degrees Celsius and B is having 75 degrees Celsius. If you take out the difference in boiling point, that is 40 degrees, 75 minus 35, that is 40 degree. If you are converting this Celsius into Kelvin by adding 273 to this, you will get 308 Kelvin, and here 273 when added to this, you will get 348. Again the difference is 40. So either you are taking in Celsius or in Kelvin, no problem. Just I am saying the boiling temperature difference should be more than 25 degrees. Okay. So if more than 25 degrees boiling point difference is there, in that case we perform simple distillation. Simple distillation is done. How to do this? First of all, we are taking a boiling retort. Boiling retort meaning round bottom flask in which strong heating can be done. This apparatus is round from the bottom also. So round bottom flask. In that round bottom flask, mixture of acetone and water is taken. Why I am taking this mixture here? Because acetone and water possess higher boiling point difference. Here I have written acetone is having 56 degrees Celsius. Water, you are knowing students, it boil at 100 degrees Celsius. So difference in boiling point temperature is 44 degrees, isn't it? So more than 25, that's why we are performing which distillation? Simple distillation. So here in this boiling retort, R-E-T-O-R-T, retort, mixture of acetone and water is taken in this with a thermometer fitted into it so that we can able to observe or measure the temperature. if this mixture is heated by using some burner, keeping in mind that boiling point of acetone is 56, so up to 60 degrees Celsius we are raising the temperature so that all acetone get evaporated, vaporizes, leaving behind what? Water, because water will boil at 100 degrees Celsius. So below 100 degree it will not boil. Okay, so only at 56 degrees Celsius, as the temperature is rising, we cannot deal with exact measurement in the thermometer. So if you are providing heat, temperature can rise up to 60 or 65 degrees, no problem, because the difference is above 25 degrees. So here, as the temperature boiling point of acetone is reached, acetone start vaporizing, and that vapors pass through this delivery tube. This is called delivery tube, and over the delivery tube a water condenser is fitted. ये आपको दिख रहा है, हॉट वाटर यहाँ से मैंने कोल्ड वाटर डाला है, वो सर्कुलेट हो रहा है इस डिलीवरी ट्यूब के आसपास, and after taking the heat from this delivery tube, because vapors are moving from through this delivery tube, so that vapors are hot, that hot vapors provide or loses their heat to the water which is circulating around this delivery tube. So all the heat of these vapors is given to this cold water which is circulated outside, and the vapors becomes cool, and when you condense the vapors, cool the vapors, they get converted into liquid form, and thus this acetone is collected here. Here cold water I am giving, hot water is coming out from this, water jacket is there, it is called water condenser. Okay, it is called condenser. So here this whole phenomena is of simple distillation. Again I am taking, students, in this round bottom flask, mixture of acetone and water is taken. Acetone and water have boiling point difference more than 25 degrees. As this mixture is heated, firstly acetone, which is having lesser boiling point, get evaporated, and that vapors of acetone are cooled down, and thus acetone is collected in the liquid form, while water remain behind in the round bottom flask only. Why thermometer is required? To measure, to keep the temperature up to 56 or 60 or 65 degrees Celsius only. As the temperature start rising, this burner is removed so that temperature can be maintained. So thermometer is taken to maintain the temperature. Okay, otherwise if we continuous heat this mixture, water will also start evaporating and come up with acetone. So in this way, students, you have observed that if the components are having boiling point difference more than 25 degrees, then we separate that components by which method? Simple distillation method. Okay, students. Now a new thing for you. If suppose the boiling point difference is less than 25 degrees, कम हो गया 25 degrees से, then what is done? Then simple distillation is not done. Then fractional distillation is performed. Fractional distillation is performed. What is this fractional distillation? Fractional distillation involves a special apparatus called fractionating column. Fractionating column. Okay, students? What is this fractionating column actually? Same type of arrangement I am taking here. This is a round bottom flask having mixture. Here mixture is present. And in this round bottom flask, one fractionating column is attached. That fractionating column contain beads here, BEAD, beads, मोती जैसे structures यहाँ पर होते हैं. And thermometer is certainly there. As the temperature rises, suppose here I have taken this time mixture of alcohol and water. Alcohol possesses boiling point 78 degrees Celsius while water has 100 degrees Celsius. So if you take out the difference, it is less than 25 degrees. So definitely we cannot perform simple distillation. Here we have to perform fractional distillation. So what is done here? As this mixture of alcohol and water is heated, firstly which will evaporate? Alcohol will evaporate. But since the difference in boiling point is less, so some water molecule also, because rise in temperature is so fast in the thermometer that some of the water molecules also get evaporated. But as this strikes with the glass bead in the fractionating tower, they lose that water molecules, lose their energy to that beads, and ultimately that energy is taken by alcohol molecules, and alcohol evaporate and form vapors, and that vapors when passed through the delivery tube, when cooled down by using this condenser, students, again the same thing as we did in case of simple distillation. Here also that vapors are cooled down, and that vapors after cooling forms liquid, and in this way alcohol can be obtained in this beaker. Alcohol can be obtained. While water, as it is striking, water is having higher boiling point. So as it is getting interrupted by these glass beads, as it is striking, that vapors of water when strike with that glass bead, they lose their energy to the glass bead and again get converted into liquid, and liquid comes back into the flask. So what is the reason of taking these glass beads? They prevent the component of higher boiling point to get evaporated. Okay students, it prevent these glass beads, or the fractionating tower is separating the two components of lesser boiling point difference. Is it clear students? So in this way, mixture of components having lesser boiling point difference can be separated by which method? Fractionating column, or by the method fractional distillation. It is not a simple distillation, students. Here I am taking one more example, students, of fractional distillation, like atmospheric air, air around you. That also contain many components in it. Like if we observe the component, maximum percentage is of nitrogen. Nitrogen is 78% in air, 21% of oxygen, exact percentage 20.9, it is equivalent to 21% of oxygen is there, 0.03% carbon dioxide, inert gases, you know students, helium, argon, neon, xenon, krypton. I think three you are knowing students, helium, neon and argon. So these are called inert gases, friends. How and why they are called, I will tell you in next chapter, students. So here inert gas, argon is there in the atmosphere. CO2 and argon, they both are in traces. Traces meaning, students, very less amount में होते हैं CO2 and argon. And water vapors are also present in the air, but the percentage of water vapor is not fixed at every place. In the coastal areas, water vapors are more in air, while in the dry places, water vapor content is less. So these all components are present in the air. Then how can we separate these constituents? So a flow chart I have made here, students. Firstly, air is compressed. Compressed, you know, students, by applying pressure and cool. So, how to compress air? By increasing the pressure at low temperature. So, at that, in these conditions, if we are applying these conditions on air, air get liquefied. Okay, like at home you are using LPG. What is it? Liquefied petroleum gas. So here also we are liquefying this air, atmospheric air. So air get converted into which form? Liquid form. Now we warm air slowly by releasing the pressure and warming slowly. So as the air is warmed slowly, now mainly we are separating the three components nitrogen, argon and oxygen. Here I have written the boiling points of different components. Oxygen minus 183 degrees Celsius, argon minus 186 and nitrogen minus 196. If I ask you that which value is the least? Which value is the least? Minus 196 degrees Celsius is least because negative sign is there. So least is the boiling point in case of nitrogen. अगर boiling point बहुत कम है तो थोड़ा सा भी टेम्परेचर राइज करने से क्या होगा? सबसे पहले इवेपोरेट होगा. So in the fractionating tower, different outlets are there at different temperature. So in that fractionating tower, firstly this liquid air, firstly nitrogen get evaporated. In the gaseous form it will come out because it is having least what? Boiling point. Then comes argon minus 186 degrees Celsius. And if we are keeping 186 degrees Celsius only, oxygen will be collected out in liquid form because its boiling point is minus 183 degrees Celsius. So in this way, in the fractionating tower, we can separate different constituent of air. One diagram also I have drawn here, students. You can see. Firstly, we are filtering the air, atmospheric air. So firstly, we have taken this air from the filter. We have filtered the air to remove suspended particles. Okay, dust, smoke, that particles we are separating first by filter. Then that air is taken in. Then this air is passed in the compressor. This is compressor. Here I have written air under pressure. So air under pressure meaning it is in the compressor. Okay, this is compressor where we apply compressor. Okay, where we are applying very high pressure. As we compress the air molecules come closer, and if that air molecules come closer, they strike with each other, and as they strike with each other, they becomes hot. Okay, students, they becomes hot because as the molecules of gas are coming closer, they will strike with each other and the molecules becomes hot. Now this hot air is taken in a condenser. In this chamber, what is happening? Cold water is circulated. This is the spiral pipe, metallic, where cold water is circulated. So when the air comes in contact with this pipe, cold pipe, air get cool, and as the air cool down, it forms liquid. So this becomes liquefied air. Okay. Now that liquid air is taken in the next chamber where carbon dioxide comes out. As we are applying very high pressure, students, carbon dioxide get converted into dry ice. If you are remembering, students, CO2 in the solid form is dry ice. So as in the first chamber we applied very high pressure, so carbon dioxide content get converted into solid form and it comes out as dry ice. Is it clear, students? And rest of the liquid air is now sent through this pipe to a expansion jet. Expansion jet क्या होता है? Expansion jet, here pressure is released. Like in the gas cylinder at home which we are using, we turn the knob on. So what we are doing, we are opening the expansion jet. From there, pressure is getting released and liquid air get converted into gaseous form. Isn't it, students? And that gas we burn in the burner to cook our food. Okay. So here as we are passing this liquid air through expansion jet, now air and then the air is warmed slowly. Expansion jet से आके हम क्या कर रहे हैं air को? Air is warmed slowly. As air is heated, warmed slowly, then air start boiling. Here we know that nitrogen is having least boiling point, so it will come out first. We have done now the boiling point 196 minus nitrogen comes out first, then argon secondly minus 186 degrees Celsius, and oxygen remain in the liquid form only because its boiling point is minus 183 degrees Celsius. So in this way, so it is taken out as liquid form only. So in this way, we can separate out different constituents of air which possess very less boiling point difference. Isn't it, students? So this fractional distillation is entirely a new topic for you, students. If you have any problem, you can ask me again and again. I am asking you to ask doubts if you have, but none of you are turning up. That means you are not having any doubt. So according to me, this fractional distillation is a very new topic for you. If you have any type of confusion, you can ask me. I will take that confusion in my next video to explain you. Okay, students, do it nicely. For today, this much is there. Thank you, students.